Hello everyone. I welcome you all to the e-videos track for Unannounced Syllabus under the Regulation 2021. Today we are going to see the session on the topic round robin, that is RR scheduling algorithms from the second unit process management in the course CS 3451 Introduction to Operating System. Myself Dr. Sirani. And let us see, the objective of today's session is to know about the round robin scheduling algorithm. The outcome of this today's session, the students may be able to understand how the round robin scheduling algorithm is being applied. Here is the outline of today's session. First, we'll see about what is the definition of round robin scheduling algorithm and what are the advantages and disadvantages of RR scheduling algorithm, and let us see some of the solved problems. The round robin scheduling algorithm is designed especially for the time sharing operating system. It is similar to that of the first come first served scheduling algorithm, but preemption is added to enable the systems to switch between the processes. So in this round robin scheduling algorithm, a small amount of time, which we call it as a time quantum or time slice, will be defined, which is generally from 10 milliseconds to 100 milliseconds in length. So the ready queue means whatever the process which need to be assigned for the processor will be placed in the ready queue, which will be treated as a circular. The CPU scheduler goes round the ready queue, which will allocate the CPU to each and every process for a time interval of up to one time quantum. The CPU scheduler picks the first process from the ready queue and set up the timer to interrupt after one time quantum and continue the dispatching the processes. So one of the two things will happen here. The first case is the process, if the process CPU burst time is less than time quantum, means the process itself will release the CPU voluntarily. The scheduler will then proceed to the next process in the ready queue. In the second case, if the CPU burst time is greater than that one time quantum, the timer will go off and will cause an interrupt to the operating system. The context switch mechanism will be executed and the process will be put at the tail of the ready queue. The CPU scheduler will then select the next process in the ready queue. Next, we'll discuss what are all the advantages and disadvantages of round robin scheduling algorithm. So round robin is effective in a general purpose time sharing system or transaction processing system. So each and every process will be treated equally. So there will be a fair treatment for all the processes. And overhead on the processor is very low. And RR scheduling algorithm will also provide a good response time for the short processes. So these are the advantages of round robin scheduling algorithm. The disadvantages of round robin scheduling algorithm is that care must be taken in choosing the quantum value. The processing overhead is there in handling clock interrupt. So the time quantum need to be maintained. So there will be the handling of the clock interrupt is overhead, which will be processing overhead in case of RR scheduling algorithm. And throughput is also low if the time quantum is too small. Now let us see some of the problems how to apply the RR scheduling algorithm. Consider the following set of processes that arrive at 0, a time quantum of 4 milliseconds. Okay, so 3 processes are involved and the CPU burst time is given. 24 millisecond for the process, CPU burst time is 24 millisecond for the process P1, 3 millisecond for the process P2 and P3. Let us see how to solve using RR scheduling algorithm. So here the gunshot is depicted here. For the process P1, P2, P3, the arrival time is 0. The start time you can find out using this gun chart. The start time for the process P1 is 0 and for the process P2 is 4 and for the process P3 is 7. Okay. And the wait time can be calculated using the formula start time minus arrival time. Okay. For the process P1, the wait time is 10. After the 4 time quantum, next the process P1 comes here. Okay. So 10 minus 4. The waiting time for the first slot is 4. So 10 minus 4 will get the waiting time is 6 for the process P1. And for the process P2, the waiting time is 4. It is not repeated again in the gunshot. Process P2 is not repeated again. So 4 minus 0 is 4 is the waiting time for the process P2. And for the process P3, the waiting time is 7. And it is not depicted again. Since 3 millisecond is less than the 4 time slot, the timer will go off. Okay. So the waiting time for the process P3 is 7. Okay. After finding the waiting time for each and every process, we need to calculate the average waiting time is 6 plus 4 plus 7 will get 70, which need to be divided by 3. 17 divided by 3 will get the average waiting time as 5.67 milliseconds. The finish time is calculated. See, for the process P1, using this Gantt chart, the finish time is 30. So, which will be depicted in the tabulation. And for the process P2, the finish time is 7 milliseconds. And for the process P3, the finish time is 10 milliseconds. So from the Gantt chart, you can directly find out the finish time. Next, calculate the turnaround time is the difference between the finish time and the arrival time. So since the arrival time is 0, whatever the finish time we are getting will be the turnaround time. So on calculating the average turnaround time, so 30 plus 7 plus 10 will get 47 divided by 3 will get the average turnaround time as 15.67. Okay. So since the process P2 and P3 have the CPU burst time is less than the time slot 4 time quantum, it will not be, the processor will not be assigned once again. Only the process P1 will be assigned in a repeated manner. After the every 4 time slots, it will be, the processor will be assigned to this processor P. Okay. In this manner, you have to solve using the RR scheduling algorithm. See the next example problem. In this problem, the time quantum given here is 20 milliseconds. 4 processes are depicted, and CPU burst time is given for every 4 processes. The arrival time is 0. And the start time you can calculate from the Gantt chart. The start time is 0 for the process P1, and the start time for the process P2 is 20, and start time for the process P3 is 37, and the start time for the process P4 is 57. And we need to calculate the waiting time. Okay. So the waiting time for the process P1 is calculated here. See, after the 4 processes P1, P2, P3, next the start time for the process P1 is 77. So 77 minus the time quantum 20 plus, next you have to check where the P1 comes next. Process P1 comes next. 121 minus this 97. Okay, 121 minus 9. 97. That is the completion of the 3-year P1 process. Okay. So 77 minus 20, you'll get 57 plus 121 minus 97, you'll get 24. 57 plus 24, you'll get 81 milliseconds. That is the waiting time for the process P1. So in the same manner, we need to calculate the waiting time for the process P2. See the process P2, the waiting time is 20, and we need to check whether the process P2 comes in the second time or third time in the gunshot. So there is no other possibility. So 20 minus 0, 20 millisecond is the waiting time for the process P2. And for the process P3, the waiting time is 37 minus 0 plus, we need to find where the next time P3 is depicted in gunshot. So 97 minus 57, that is the end of this P3. Okay. So 97 minus 57 plus, next we need to find where P3 comes again. So 134 minus 117. Okay. So 37 minus 0 plus 97 minus 57 plus 134 minus 117. So upon calculating this, we'll be getting 94 milliseconds will be the waiting time for the process P3. Next, we need to calculate the waiting time for the process P4. So what is the waiting time for P4 is 57 minus 0. Next, we need to find where the P4 comes again. So 117 minus 77. That is the ending of this P4. Okay. So 57 minus 0 plus 117 minus 77. 57 plus 40, you'll be getting 97 milliseconds for the process P4. This will be the waiting time. So after finding all the waiting times, we need to calculate the finish time of each and every process from the Gantt chart. The finish time of process P1 is, you can calculate here. See here, 134 milliseconds. Okay, that is the finish time for the process P1. And for the finish time for the process P2 is 57. Okay. And for the process P3, the finish time is 162. Okay, 162. And for the process P4, it is 121. So from the Gantt chart, you can directly find out what is the finish time for each and every process. And turnaround time, since the calculation is finish minus arrival, since it is all 0 for all the process, whatever the finish time you are getting, that will be the turnaround time. Okay, we need to find the average turnaround time. It is not required. Just you can fill up this tabulation. So the average waiting time for all the 4 processes is 73 milliseconds. The thing is that you need to focus on the 20 millisecond time quantum for each and every 20 time quantum. The processor will be moving on to the next process. In this manner, you need to solve the given problem using the round robin scheduling algorithm. So these were the references used for preparing the slides. Thanks for watching.